This podcast is going to be on naming polyatomic ionic compounds, and we will do regular polyatomics and variable polyatomics. And you'll need your pink sheet. I took a picture of the sheet, this one here. It doesn't look so pink, however. I apologize. And it's quite blurry, so you're going to have to pretend I know what I'm reading on there. So let's name MgNO32. Mg is magnesium. And then you have to locate NO3 on this chart. And NO3, if you scour through here, it is on here somewhere. I believe it's right about there, nitrate. And you just name it nitrate. Now, why were there no Roman numerals in this one? That last podcast, you had me all tripped up with those Roman numerals. Well, if you find magnesium on the chart, you'll find that magnesium always is a 2+, and it'll never change its charge, so you don't need to say which one it is. This is CaSO4. If you look up Ca, it's going to say calcium. It's not a variable charge because it's always a 2+. Then you look up SO4, and it's going to tell you, if you find it way over here, that it is sulfate. So it's calcium sulfate. Whoa, hold on with this one. This one looks a little scary. We got a Cu, then we got this chunk of bunk. So, first of all, let's name Cu. Copper. And if you look at your periodic table, it has more than one charge, so you're going to need a Roman numeral. See if you can identify what that is. And that is in that upper left-hand corner there. It's called acetate. And so now we have to figure out that Roman numeral charge. So acetate tells us it's in the group that's a 1- charge, so that whole thing there is a 1-. And there's parentheses around there, and there's one of those. If we have one copper, so if we have 1 and 1, and that's a 1-, then that means that copper must be a 1+. So it's copper Roman numeral 1 acetate. Let's try this one, FeNO33. Notice the parentheses around here. The 3 out here tells me that I have 3 NO3s. For example, NO3 once, NO3 twice, NO3 thrice. I like that. Twice, thrice. So we name Fe, that is iron. You look on your periodic table, it has more than one charge. You have to say which one it is. Have you found NO3 yet? NO3, I think, is a little further down on this chart, and it is nitrate. You can find the charge out from here. So NO3 is in this group, which is a 1-. So you have 3 of those, and they're a 1- charge. So in your head, that's a total of 3-. And if you have one of those, then this must be a 3+ to be equal and opposite. You can kind of see the tic-tac-toe equal and opposites there. So this must be iron Roman numeral 3 nitrate. Now we're going to write the formula. So we have sodium oxalate. Sodium is Na. Na is in the 1+ column, so it's a 1+. Now oxalate's a tough one to find. I see it right there. Again, if you see the word ate or ite, it's from the pink sheet. It's a polyatomic. So oxalate is C2O4 2-. Okay, I think I'm done being interrupted by my children. So I have Na with a plus and a C2O4 with parentheses around it. That is a 2- charge. Now this is a little bit like MC Hammer. You cannot touch what's in the middle of those parentheses. You can't change how many C's or how many O's there are. You just take it as it is and love it. So you have to figure out how many you need of each thing. And as in most cases, you could bring the 2 down there, and there's a 1 there, and you could bring it over there, and you would have success. So Na2, C2O4. Now I know exactly what you're thinking. You're thinking, holy cow, Miss A, 2, 2, and 4 are all divisible by 2 and can be reduced. Heck no, they cannot in this case, because this thing is a unit and it cannot be reduced. It came that way, it will stay that way, or it will not have the name oxalate. So let's try magnesium hydroxide. Magnesium is Mg. It's a 2+. Hydroxide is in this column here. It's an OH. They always go together, one O and one H, and it's a 1-. So if you bring that 2 down there and that 1 down there, you're going to have success. So Mg, oh, Miss A, you clearly need to go to bed. It's far too late. Mg parentheses OH2. I knew it looked wrong when I started writing it. So it's magnesium hydroxide. You need 2 OHs to balance out the 1 Mg that has a 2 plus charge. Let's try one more. Iron Roman numeral 3 chlorate. Now the Roman numeral here comes in super handy. It's just when you go in reverse that it's a little bit frustrating. So that tells me iron is a 3 plus charge. Now I have to find chlorate. It is going to be in this group. I think it is maybe that one right there. ClO3. I like to put my parentheses around it with a 1 minus. So I'm going to need 3 of these units, ClO3s, with their little parentheses and charges. So that would be 1, 2, 3, a 3 minus, and that would counterbalance the 3 plus. So your final answer is Fe parentheses ClO3 with 3. Now sometimes I ask some strange questions on a test. I might ask you how many oxygens there are. So you FOIL this 3 through just the parentheses, not over to Fe. That's not your land. So 3 times 3 is 9, so you'd have 9 O's. And 3 times 1 Cl would give you 3 Cl's in total. I hope you enjoyed this podcast on polyatomics, because I do enjoy polyatomics. They're a blast.